Let's read number 3. Suppose the demand per week of a product is 100 units when the price is 58 and 200 units at $51. Determine the demand equation, assuming that it's a straight line. So for now, all we have is the straight line, the linear function. So for now, we will assume a linear or straight line relationship between price and quantity. That's all we have. We only have a straight line. So let's just use that for now. So I have my price, let P represent the price. And remember that's price per unit. And let Q, we're going to stick P and Q in this type of question. Let Q represent the quantity, or the number of units. In demand. So I'm looking for a straight line, a linear equation to describe the relationship between P and Q. So for us, the way we see Q, I see Q as the X variable and P as the Y variable. Even though they have different names, I'm so familiar with X and Y. This is the role that P and Q have. So I'm looking for an equation P equals MQ plus B. That's sort of the standard form of the supply and or demand equation.
How do you know which one you're assigning the X and how do you know which one you're assigning the Y?
For our purposes, in this type of setting, it's always going to look like this. But I can very easily swap them.
So you always want the Y to be the price per unit?
We're going to stick to that.
And the X the number?
But you can very easily swap them. My equation might look different, but it's still going to give me the same relationship. We're going to stick to that. Always do P as the Y and Q as the X, just for consistency. But there's no real reason. You can't just swap them if you prefer. Now what do I know? I have to find these guys. What do they give me? They give me that the price is 58 when there's a demand of 100 units, and the price is 51 when there are 200 units in demand for the week. So they're not giving me the B, question mark, question. So let's do, if they're not giving me the value of B right away, then I'll do the slope first. Now I remind myself what is slope. It's change in something over change in something else. What are these somethings? Which one goes at the top? Y? Which one is that? V. Remember the X and the Y aren't actually defined. They're just, I'm linking them because I'm so used to X and Y. I have a P and a Q. So I can't write a Y as X. Not sure if it's that funny, but it's pretty funny. I think he's happy that the day is done. It's Halloween. He's going to go trick or treat. Okay, so I just pick a first point, or a first pair, this pair, and the second pair, this one. And I go second minus first. The p value is 51 minus 58. The q value is 200 minus 100. What do I get? I get negative 7 over 100. Now you can leave it like that, or you can write negative 0.07. Doesn't matter. They're all the same. Determine the demand equation. Well, let's update what I have so far. I'm still looking for this B. Still looking for B. How can I find the value of B? How can I find B?
You substitute P and Q.
Which P and which Q? I can choose which one, which pair I want. Doesn't matter. They both satisfy the equation, so I can use the first one, put it in. 58 equals negative 0.07 times 100 plus B. So 58 equals negative 7 plus B. So B is equal to 65. And let's update my equation. P is equal to negative 0.07 Q plus 65. So based just on the question, that's what they're looking for. They're just looking for the equation. But a much more valuable skill is to look at this equation and interpret, well, how did the price and the quantity actually change relative to each other? That's all in the slope. It's all in the slope. So the slope m, negative 0.07 over 1. What does that mean? This was change in P over change in Q. So an increase in demand of 1 unit corresponds, this line is in my way, corresponds to what? If the number of units increases by 1, how does the price change?
Decreases by 0.07.
So a decrease of 7 cents. Another way you can see it is if I decrease the price by 7 cents, there's 1 more unit in demand, or the demand goes up by 1. So I want to be comfortable saying interpreting the slope in different ways, saying it in different ways. Any questions on my interpretation? Yes?
Could you move the negative to the 1?
Yeah, absolutely.
Because then what would you say if the negative reflects the 1?
Okay, let's do it. If I want to see the slope as 0.07 over negative 1, it's the same value, Then I'll say, well, what do you want to say? Which one do you want to start with? I can say it many different ways. What do you want to say? Do you want to start with the units or the price? Price. So then if the price per unit increases by 7 cents, then the demand decreases. So C decreases by how much? By 1 unit. So many ways you can say it, but it's all from the slope. Where you want to put the negative doesn't matter, but it does affect what your sentence is going to say. These slope values are all the same, but I move the negative according to what I want to, how I want to say it. Many different ways to say the same thing. All right. Number 4 I find interesting. Let's do number 4. The height of children between the ages of 6 and 10 years can be modeled by a linear function. Model just means it can be described. A linear function of age t. The height of one child changes by 2.3 inches per year, and she is 50.6 inches tall at age 8. Find a function to describe how the height changes according to time. So they define one variable for me, t, so I don't need to do that again. I'm just reminding myself what this is. This is the age of the child in years. I need a variable to represent the height, and they don't define that for me. So h for height seems intuitive. Let h represent the height of a child, or whatever. Average height of the child. Height. So just be careful. If they define something for me, I can just use it, but if they don't, I'd have to define it first. That's step 1. So what is my equation? Well, height is a function of time, so I want to find that equation. Now, if they say something is a function of something else, then it's clear which one's y and which one's x. If I say h is a function of t, t is my independent variable, h is my dependent variable. So it has to be like this. Now I'm looking for the slope, and I'm looking for the value of b. But let me just write down what the information is that they give me and try and figure out what I can find first. So they give me that when t is 8, which is 8 years old, the height is 50.6. And then they also give me if the height changes by 2.3 inches per year. H changes by 2.3 per year. Okay? Those are the only 2 pieces of information that they give me. Can I find b right away? Doesn't seem like it. They have to give b as the y-intercept, right? So they have to give me h when t is 0, and they don't give that to me. So I can't write that in right away, so I want to do the slope next. How can I find the slope? What is the slope? Oh, let's write it over here. Slope m is change in what? Which one's at the top and which one's at the bottom? H is on top, and T is at the bottom. I have to get that right. Dependent variable, sorry, independent variable, dependent variable. H is a function of time. Y, X. Did they give this to me? They say that the height changes by 2.3 inches for every 1 year that passed. So for every 1 year, the height increases by 2.3. So I can update. My equation is height 2.3 times t plus b. Only because we're recording. The guy's going to think, oh, there's some interference because it's so consistent. I don't mind. Just okay. So now I want to find B, but they give me a pair of values that go together. So I can easily find B. If I plug in 50.6 for H, 2.3 is N, and that has to go with T equal to 8, and I can find B. What is B equal to? What is B equal to?
2.2.
Right?
2.2.
So let me update my equation that describes how a child's height changes over time. Let's make a little sketch. We don't do it a lot because it should be straightforward, but let's do it in this case. If I sketch this line, something like that, positive slope, what is this y-intercept or h-intercept? What is this value here where it intersects the vertical axis? It's right. 32.2. So this, how do I interpret this 32.2 in terms of my question, my setting? What does this 32.2 represent? When t is equal to 0. So if I want to say it without using an h and a t, just in words, what is this 32? Right. This is the height of a newborn baby. That's a big baby. So what does this mean? Does this mean we did something wrong? Based on our equation, the height, this is how the height changes. This is the age of the baby. This is 0. So this is where they're born. And they're born 32.2 inches. That's a lot of inches. It's a giant baby. So what happened?
Didn't they say only between the ages of
Right.
6 and 10?
They say this equation only applies, or it's only realistic, if t is between 6 and 10. So only for a child between 6 and 10 years is this function accurate. If I go outside of that, then I'm going to make a conclusion that says that babies are born on average 32.2 inches. And that's not correct. So let me just draw this line again, a little straighter. So only over here, 6 to 10, is this straight line, does it actually mean something? Over here it doesn't mean anything anymore. I'm losing accuracy the further away from this 6 to 10 range that I go, the less accurate I become, and I can't trust what it says anymore. Because in reality what happens, a baby is much smaller than this, and then the height increases with some sort of curve. And then, same thing, if I follow this until I'm 50, I'm going to be huge. This doesn't make any sense anymore. It sort of tapers off if I get older. So, there's good and bad news. The good news is using a straight line to describe something that makes it easy, but it doesn't necessarily apply for everything. It might just apply to a small window. And then the actual situation is more complicated than that. When the child's really young, or when the person's older, it changes. It's not a straight line anymore. But between 6 and 10, it's reasonably accurate. So it's something to be aware of, that if it's a certain function that's describing a certain range, it might not be as accurate if I go outside of that range. I need some other function, some other equation to describe that situation. So it was nice to know, to observe this. Okay, any questions on this? Let's do the last two. They'll be reasonably quick. To make absolutely sure of this slope idea. The more examples we do, the better off we'll be, because these are the questions that we want to be able to answer. Not just given a random equation that doesn't mean anything. I want the equation to mean something. Let's read number 5. An antique necklace is expected to be worth $360 after 3 years, $640 after 7 years. Find the function that describes the value of the necklace after X years. Now I'm assuming it's a linear function. That's all we have. That's all we have to work with right now. On Friday we'll see something a little bit more general, but not for now. So they define X for me. Let's just go and say it's the age of the necklace. Necklace? Yes. And let's go with V for value. I don't want to always be stuck with X and Y. Let's go with V. Value of the necklace. I want V as a function of X. And I'm assuming that it's a linear function, straight line. Again, it's not going to be accurate for any value of X for any number of years, but hopefully there's a small window where it is accurate. Again, I'm looking for the values M and V. Now, what do they give me? They give me X and V pairs of values. After 3 years, the value is 360. After 7 years, the value is 640. So what is the slope? Change in value over change in X. Pick a first point and a second point. Then the change in V is 640 minus 360 over change in X, 7 minus 3. What do I get? 640 minus 360, correct? 280 over 4, which is 70. That's a nice number. So the value of M is 70. So I update my equation. V equals 70x plus B. I can use any pair, 3 and 360, to find the value of B. So the value of 360 goes with the value of X of 3. And I can find the value of B. 70 times 3 is 210. 210 you take away from 360. Looks like 150. And I have my value equation like that. And if I want to represent this graphically, positive slope, 70 is positive. I can interpret the y-intercept. At the time it's purchased, the value is 150, and it goes up like this. It's not accurate forever, but hopefully for a fair number of years. And then I can interpret the slope. How do I interpret the slope? Slope is 70 over 1. What does that mean? That means every year the value increases by $70. If the number of years go up by 1, the value goes up by 70. So it's a reasonably good investment, it seems like. $70 every year, maybe. Any questions on that? So as we're doing these questions, we see the same issues, the same things coming up over and over. The slope is definitely the most important. Example 6. Now I have demand again. Demand per week for a CD is 26,000 copies when the price is $12 each. 10,000 copies when the price is $18. Find the demand equation, assuming that it's a straight line. So for the demand and supply problems, my variables are always going to be the same, but I still need to define them. Let P represent the price, and that's per unit. Let Q represent the number of CDs in demand. Number of CDs. Just to make the numbers a little nicer, let's say here a number of CDs in thousands. So my numbers are a little bit nicer. It's just a personal choice. You don't have to always do that. What is my equation? Well, for this demand-supply equations or problems, my P is always going to be the role of the Y variable, the dependent variable, and my Q is going to be the independent variable. I just have to find them. So let's see what they give me. They give me pairs of values that go together. Quantity of 26,000, so Q is 26 when the price is $12, and 10 when the price is 18. So let's find the slope. M, I remind myself, it's change in what over change in what. Which one's where? Which one's at the top?
Y.
Which is? There's no Y or X in it.
Oh, change P over Q.
Change in P over change in Q. If I've defined a P and a Q, and in a test you write an X and a Y, I'm going to be forced to take something away, and I don't want to do that. So I think of them as X and Y, but their names are P and Q. So watch out for that. So M is equal to, I pick a first point and a second point, doesn't matter which one. Second minus first, so 18 minus 12 over 10 minus 26. What do I get? Almost done. 6 over negative 60. Or you can write this as, doesn't really matter, negative 3 over 8. Or you can write it as negative 0.375, whatever you prefer. Really doesn't matter. Whatever you prefer. Some people like fractions, some people like decimals, doesn't matter. So that's my slope. So let's update my equation. P is equal to negative 0.375 Q plus B. Use any point you want, like the first one. Plug it into the equation to get the value of B. So 12 is equal to negative 0.375 times 26 plus B. B is equal to 1. B is equal to 1. Almost done. 21.75. So my equation is negative 0.375Q plus 21.75. And this does have the shape that I expect for demand equation, demand curve, top left to bottom right. As the price goes down, the demand increases. Can we interpret the slope? Just a little, just at the end. Make sure we understand how to interpret the slope. For me personally, it doesn't matter. You can use this one, you can use this one. Doesn't matter.
Question.
Which one do you want to use?
Why Q is 26, not 200, 26,000?
I just defined it to be in thousands, just to make the number smaller.
Oh, yeah.
But Q equal to 26 represents 26,000
Yeah, but the
CDs.
result is different.
My equation is going to look different, but the result's the same. If you want to know what is the price if I sell 15,000 CDs, I put 15 in there.
Oh,
So it's based on how I chose to define Q. You can define it in thousands, doesn't matter, as long as you stick to that. Let's interpret the slope quickly. Negative 0.375 over 1. That'll do. So if, which one's at the top and which one's at the bottom? Quantity, the bottom. So if the demand increases by 1, what happens to the price? The price decreases by 37.5 cents. So make sure that you can interpret the slope. One of the most important things.